Okay, so some things about binomial coefficients. First thing here, recall that a binomial is a polynomial that has two terms. In this section, we'll study a formula that provides a quick method of raising a binomial to a power. To begin, look at the expansion of x plus y to the n for several different values of n. So notice at first we have 6 plus y to the 0, which is 1, because anything raised to 0 power is equal to 1. Then x plus y to the first is just x plus y. X plus y squared, we would have to do FOIL, and so you get x squared plus 2xy plus y squared. X plus y to the third, you would have to do FOIL, and you get to two of them, like in the previous step, and then you'd have to multiply that answer times x plus y, and you'd get the 1x cubed plus 3x squared y plus 3xy squared plus y cubed, and we could keep going from there. And as you can see, now a couple things you want to notice here. One of them is how many terms each one has. So like in that first one here, sorry, that's not my pen. The first one here, there's only one term, but my exponent was 0. On the second one, there's two terms, but my exponent was 1. My next one, there's 3 terms, but the exponent there was only a 2. So what we're finding is the number of terms is equal to n plus 1, where n is your exponent. Alright, we also can see that x and y have symmetrical roles. The powers of x decreases by 1 in successive terms, whereas the powers of the y increase by 1. So again, if you look down at the bottom row there where it has x plus y all raised to the 5th, notice you've got your x to the 5th, and then you have an x to the 4th, and you've got an x cubed, you've got an x squared, you've got an x, and then the last term you don't have an x. Technically you could say you have an x to the 0, because x to 0, there's none there, so it's not there. Also, then you can look at your y value, and you'll see at first you have no y. So kind of like that x one, this is like a y to the 0, then you have a y to the first, a y to the second, a y to the third, a y to the fourth, and a y to the 5th. And this is where you'll hear me later in different videos refer to your x term and your y term. I'm talking about where your x is your first term and your y is your second term when it's raised to some exponent n. Okay. Also notice though, if x and y don't have any coefficients other than a 1, it's also symmetrical with your numbers, and that's going to help us out somewhere else later, because if you look back at that last row again, notice your coefficients. You have a 1, then a 5, 10, then 10, 5, and a 1. They're symmetrical there. Check out the row above that. You got 1, 4, 6, 4, 1. So they're just symmetrical again as far as their coefficients as well. But of course those coefficients would change if I had a number other than a 1 in front of the x or the y. Also, something else to watch for is your exponents in each term is equal to the exponent in the problem. So like on this last row again, my exponent was a 5. So if you notice your first one, all you have is a 5. In the second term, you have a 4 and a 1, and if you add those, 4 plus 1 is 5. In the next term, you have a 3 and a 2. 3 plus 2 is 5. Next one, you have a 2 and a 3. 2 plus 3 is 5. The next one, you have a 1 and a 4. 1 plus 4 is 5. And in the last one, you have a 5. So they'll always add up to be whatever the exponent is.